Okay, let's have a look at solving the integral from 0 to 2, 0 to z, negative x minus z to x plus 2z of the function x with respect to y first, with respect to x first, and then with respect to z. Okay, the reason why we know it's dy dx dz is because these limits are dependent on variables and they don't depend on y, so we must integrate with respect to y first. These limits depend only on z, so it can't be z, so it must be x, and then these are constants, so they must be z. Okay, so let's find this is equal to outer integrals remain unchanged, 7 to 0, and this becomes xy, and we're going from y equals x plus 2z to y equals negative x minus z. So we just have to sub those in, dx dz, so it's equal to 2 0 z 0 x times x plus 2z minus x times negative x minus z dx dz. Okay, so that's equal to 2 to 0 z to 0. Now we just got to clean this up, so that's x squared plus 2xz minus minus is plus x squared plus xz dx dz. So that's equal to integrals 0 to 2, 0 to z. That's equal to 2x squareds plus 3xz dx dz. So now we just have to integrate with respect to x. 2 to 0. Now we're integrating, so it becomes 2 on 3 x cubed plus 3 on 2 x squared z from x equals z to x equals 0 dz. So that's equal 2 to 0. Subbing in x equals z, I have z cubed, 2 on 3 of them, plus subbing in x equals z, I have z squared times z, which is z cubed, and 3 on 2 of them, dz. And when I sub in x equal to 0, I get 0 here. So cleaning this up, 2/3 plus 3 on 2, well, that's 4/6 plus 9/6 is 13 on 6. Sorry, 2 to 0, 13 on 6 z cubed dz, which is equal to 13 on 24 z to the 4, so 6 times 4, between z equal to 2 and z equal to 0, which is equal to 13 on 24 2 to the 4 minus 0. So 2 to the 4 is 16, so I have 13 times 16 on 24. So as a tip to work this out, do prime factorization. That's 13 times 4 times 4 divided by 6 times 4. So one of those cancel. 4 will cancel, give me a 2 and a 3. So 13 times 2 is 26 on 3. And that will be the solution to my integral. Okay, so that's a triple integral with variable limits. It's the same technique, except when you're subbing in here and over here, you're going to have limits that depend on x, y's, and z's rather than just constant limits like in question 1. Okay, so the answer to this was 26 on 3.